The universe, with its vast expanse of 350 billion galaxies, each containing over 100 billion stars, was once the size of a melon. This mind-boggling fact serves as a humbling reminder of the strange and often unfathomable nature of reality. Among those who strive to make sense of such mysteries is Michio Kaku, a renowned theoretical physicist known for translating complex scientific concepts into accessible insights. However, his latest revelations about quantum physics have sparked both awe and concern, raising profound questions about the future of humanity and our place in the cosmos. The power and peril of quantum physics. Quantum physics, the science of the very small, is not merely an academic curiosity. It is a force shaping our reality. It governs the behavior of subatomic particles such as electrons, photons, and quarks, which defy conventional logic by existing in multiple places at once, teleporting across space, and influencing each other instantaneously over vast distances. This phenomenon, known as quantum entanglement, was famously described by Albert Einstein as spooky action at a distance. While entanglement may seem like an esoteric concept, it has real-world applications that could revolutionize technology and potentially threaten global security. Quantum computing, a double-edged sword. Quantum entanglement is the foundation of quantum computing, a revolutionary field poised to transform industries from medicine to artificial intelligence. Unlike classical computers that process information in binary form, quantum computers use qubits, which can exist in multiple states simultaneously thanks to superposition. This capability allows quantum computers to solve problems in seconds that would take traditional computers millions of years. While the promise of quantum computing is immense, offering breakthroughs in drug discovery, logistics, and problem-solving, it also presents severe risks. One of the most alarming concerns is its ability to break modern encryption systems. This could render all existing cybersecurity measures obsolete, making bank accounts, government databases, and personal communications vulnerable to hacking. Kaku warns that we may be entering a quantum arms race, where nations and corporations invest billions to achieve supremacy in this technological frontier. The consequences of an unregulated quantum revolution could be catastrophic, shifting the balance of power on a global scale. The multiverse and the nature of reality. Beyond its technological implications, quantum mechanics challenges our fundamental understanding of reality. Kaku has extensively discussed the possibility of the multiverse, a theory suggesting that our universe is just one of many, each governed by different physical laws. Experiments in quantum mechanics support this notion, demonstrating that particles exist in multiple states until observed, implying that every possible outcome may unfold in separate parallel universes. If this theory holds, it raises existential questions about free will, consciousness, and identity. Are we merely one of infinite versions of ourselves, living out different possibilities in parallel dimensions? And if so, what does this mean for our perception of existence? According to Kaku, these are not just philosophical musings, but questions with real implications for how we understand our place in the cosmos. The dangers of playing with the quantum code. Perhaps the most unsettling aspect of Kaku's revelations is the possibility that we may be tampering with forces beyond our comprehension. Scientists have begun exploring the creation of artificial black holes in laboratory settings by manipulating quantum fields. While these black holes are microscopic compared to those in space, their potential risks cannot be ignored. Could we accidentally create a black hole that spirals out of control, consuming everything around it? While most physicists dismiss this scenario as unlikely, the mere possibility is unsettling. Quantum artificial intelligence, AI, is another frontier fraught with uncertainty. As quantum computers become more advanced, they could revolutionize AI, enabling machines to process information at unprecedented speeds. This could lead to extraordinary advancements in medicine, engineering, and countless other fields. However, it also raises the specter of AI surpassing human intelligence, a scenario that many experts consider both an opportunity and an existential threat. A quantum-powered AI would operate under the same probabilistic principles that govern the quantum world, making its behavior inherently unpredictable and potentially dangerous. The environmental and ethical quandary. The development of quantum technologies also presents significant environmental and ethical concerns. Many quantum experiments require extremely low temperatures, maintained using cryogenic systems that consume vast amounts of energy. As quantum computing expands, so too will its environmental impact. Kaku stresses the importance of considering these consequences before quantum advancements exacerbate existing global challenges. Moreover, some interpretations of quantum physics suggest that our universe may not be as real as we believe. Certain theories posit that reality itself functions like a simulation, governed by underlying mathematical principles. If true, this raises profound questions. Who or what created these rules? Are we living in an artificial construct, and if so, what happens if we begin tampering with its fundamental laws? Kaku has described this as the God question, the idea that quantum physics may ultimately reveal the nature of existence itself. But while this prospect is awe-inspiring, it is also deeply unsettling. If our universe is a simulation, could our experiments inadvertently disrupt its structure? A call for responsible exploration. As humanity stands on the brink of a quantum revolution, Kaku emphasizes the need for responsible exploration. The stakes are too high for reckless experimentation or unrestricted development. He calls for global cooperation among scientists, policymakers, and ethicists to establish ethical guidelines and safeguards that ensure quantum technologies serve the greater good, rather than becoming instruments of destruction. Education is another crucial component of this equation. The quantum revolution is happening now, and future generations must be equipped with the knowledge and skills to navigate this new reality. Understanding quantum mechanics is no longer just the domain of physicists. It is an imperative for policymakers, technologists, and society as a whole. The strange world of quantum mechanics, quantum physics, the science of the incredibly small, governs particles like electrons, photons, and quarks, entities that challenge our fundamental understanding of reality. Unlike objects in our everyday world, these particles can exist in multiple places at once, teleport across vast distances, and influence each other instantaneously through quantum entanglement. Albert Einstein famously called this phenomenon spooky action at a distance. While these properties may sound like quirks of an abstract theory, they form the foundation of real-world applications, including quantum computing. This revolutionary technology holds the promise of solving problems in seconds that would take classical computers millions of years. However, as Kaku warns, this power comes with significant risks. The perils of quantum computing. Quantum computers operate using quantum bits, or qubits, which can exist in multiple states simultaneously due to a phenomenon known as superposition. This allows them to perform calculations at speeds that are inconceivable by today's standards. The potential benefits of this technology are enormous, accelerating medical breakthroughs, optimizing global supply chains, and revolutionizing artificial intelligence. However, Kaku highlights a darker side to this power. The same quantum properties that enable such rapid computation could also render all modern encryption systems obsolete. In a world where quantum computers can break even the most advanced cybersecurity protocols, every bank account, government database, and private communication could be vulnerable to cyber attacks. Governments and corporations worldwide are engaged in a race to develop quantum supremacy, leading to concerns of a quantum arms race where power is concentrated in the hands of a few. Could quantum mechanics unravel reality? Beyond its technological implications, quantum mechanics raises profound questions about reality itself. Kaku has spoken extensively about the concept of the multiverse, the idea that our universe is just one of many, each operating with its own unique laws of physics. Quantum experiments suggest that particles exist in a superposition of multiple states until observed, leading some physicists to speculate that every possible outcome of a quantum event actually occurs in a separate universe. This challenges our very notions of free will and identity. If there are infinite versions of ourselves living out every possible scenario, what does that mean for our understanding of existence? And more unsettlingly, are we unknowingly tampering with forces beyond our comprehension? Playing with fire, the dangers of quantum experimentation. As scientific advancements push the boundaries of quantum mechanics, some experiments raise ethical and existential concerns. Researchers are exploring the possibility of creating artificial black holes in laboratory settings by manipulating quantum fields. While these microscopic black holes are theoretically harmless, the mere idea that they could grow beyond control is enough to warrant caution. Kaku also warns of quantum artificial intelligence. As quantum computing accelerates, AI could develop capabilities far beyond human intelligence, making decisions that are incomprehensible and potentially uncontrollable. If AI systems operate based on quantum principles, their behavior could be governed by probabilistic rules, making them inherently unpredictable. The unsettling prospect of a quantum-driven future. Another area of concern is the environmental impact of quantum research. Many quantum experiments require extremely low temperatures, achieved through energy-intensive cryogenic systems. If the demand for quantum computing grows without considering sustainability, we could face unintended consequences, exacerbating the very problems we aim to solve. Perhaps the most disturbing idea Kaku presents is the possibility that our universe is not as real as we think. Some interpretations of quantum physics suggest that reality is governed by underlying mathematical rules, raising the question of whether we live in a kind of simulation. If this is true, what happens if we inadvertently break the code of our own existence? Navigating the quantum frontier. A call for responsibility. Despite these risks, Kaku does not advocate halting quantum research. Instead, he stresses the importance of balancing scientific exploration with ethical responsibility. The quantum revolution requires global cooperation among scientists, policymakers, and ethicists to ensure that these powerful technologies are used for the benefit of humanity. Education is also critical. As quantum mechanics becomes a driving force in science and technology, future generations must be equipped with the knowledge to understand and navigate this new reality. Quantum physics should become a core part of science education to demystify its complexities and ensure its benefits are accessible to all. Michio Kaku's message is clear. Quantum physics is a double-edged sword. It holds the power to unlock extraordinary advancements, but also comes with dangers we are only beginning to grasp. As we stand on the brink of this new frontier, we face a choice. Will we use quantum technology to advance humanity, or will we let it spiral out of control? The quantum revolution is not just another chapter in science. It is an entirely new book. The discoveries of the past century have peeled back the layers of reality, revealing a universe stranger than we can imagine. Now, as we prepare to unleash quantum technology into the mainstream, Kaku's warnings have never been more timely or more unsettling. The decisions we make today will shape the future of human civilization for generations to come. Will we rise to the challenge, or will we become the architects of our own undoing? The choice is ours, and the clock is ticking. Michio Kaku's revelations about quantum physics are both exhilarating and alarming. They offer glimpses into a future where quantum computing, artificial intelligence, and multiverse theories redefine our understanding of reality. Yet, they also warn of the perils that come with wielding such immense power. As we venture further into the quantum realm, we must proceed with caution, ensuring that our discoveries lead to progress rather than catastrophe. Quantum physics may hold the key to unlocking the deepest secrets of the universe, but whether we use that key wisely remains to be seen.